Okay guys, so welcome to section 1.3. This is example 1. It's stuff we already done, so I'm going to go really quick. So when we're adding polynomials, we just look for like terms. So we look for variables with the same exponent. So we have x to the third and another x to the third. And so we have x to the third plus x to the third. So then we have 2x to the third. And then we have a negative x to the sixth, and negative 6x squared, and a positive 5x squared. So then we have negative 5 plus negative 6 plus 5, and that is negative 1x squared. And we have a 2x and a negative 7x. So 2x plus negative 7x, 2 plus negative 7 is negative 5, so minus 5x. And then we have the 4 that's all by itself, so plus 4. And then for example B, it's going to be the same thing. So we have x cubed minus x cubed. X cubed minus x cubed cancel out. We have negative 6x squared and a 5x squared. So we have negative 6x squared minus 5x squared. Negative 6 minus positive 5. Since there will be we have a negative minus a positive, so we'll really be adding, so we'll have negative 11x squared, and then we have a 2x and a minus 7x, so 2x minus negative 7x, so we have 2x plus 7x, so that's plus 9x, and then we're just left with this 4, and it has no friends to go with, so just plus 4. Okay, so that's that. Okay, now on to example 3. This is also something that we've done before. It's multiplying polynomials. So you just take each term in the first polynomial and multiply it with each term in the second polynomial. So we'll take 2x and distribute it to the x squared, we'll distribute it to the 5x, and we'll distribute it to the 4. So 2x times x squared is 2x, and remember the exponents add, so it becomes to the third power. And then 2x times negative 5x is minus 10x. And once again, the exponents add, so it's x squared. And then we have 2x times 4, so that's plus 8x. And now we take the 3, and we'll distribute the 3 to everything. So the 3 goes to the x squared. So 3 times x squared is 3x squared. 3 times negative 5x is minus 15x. And then 3 times 4 is plus 12. And then if we just want to put that all together, combining our like terms, we'll just add everything up. So I have 2x to the third. Negative 10x plus 3x is minus 7x squared. And then I have 8x minus 15x is minus 7x, and then plus 12. Okay, on to example 4. Example 4 is going to be using the special product formulas that are found in the textbook. And those are right here. Hang on one second. So here are the special product formulas right here. We have the difference of two squares that we've done in class. And then we have the sum of a square, the difference of a square, the sum of a cube, and the difference of a cube. And we'll be using those in example 4. So if you keep this up while you look at if you keep this slide open while you look at the next problems, that will kind of help you understand what I'm doing. So for problem A, we basically have the sum, because it's adding, of a square. So if we look back at what we're going to use, the sum of a square is this one right here. A plus b squared gives us a squared plus 2ab plus b squared. So my a value is 3x. So I would have 3x, but that's my a value, so I have to square that whole thing, plus 2 times a, which is 3x, times b, which is 5, plus b squared, which is 5, squared. So if I rewrite this all now, I'll get 9x squared plus 30x plus 25. And then if we look at the next example, we have x squared minus 2 to the third. So I have a difference of a cube. So if we look, cube of a difference right here, number 5, we do a cubed minus 3a squared b plus 3ab squared minus b to the third. So we could FOIL it. We could multiply this out and see where we get this from. These numbers are also from the Pascal's triangle, and you'll notice the signs flip-flop because of the negative sign. But we don't have time for that. But so if we just work this problem, so we have x squared is our a value, so we're going to take our x squared to the third minus 3 times our a value, so x squared times our b value, which is 2. It's not negative 2, it's 2, plus 3 times our a value, x squared, times our b value squared, 2 squared, and then minus our b value to the third. So minus 2 to the third. So if we do this all out, I get x to the 6th minus 6x to the 4th plus 2 squared is 4 times 3 is 12x squared minus 2 to the third is 8. Sorry, that fell off the screen. So hang on and we will go to example 5 in a second. Okay, so let's take a look at example 5 now. So in example 5, you see we're going to be applying these special formulas. So we have 2x minus the square root of y, 2x plus the square root of y. So I could multiply this out, but I'm not going to take the time to do that because I know by looking at it I have the same terms, 2x and square root of y and square root of y, but then I have them added together. So what I have one added and one subtracted. So what I know is that this is going to be one of my special formulas. I look, oh look, so I have an a plus a b and an a minus a b. So I know that that's going to be what I'm going to use. So I will have this is my a term. So I'll have that squared. 2x squared. And then I'm going to have my b term is the square root of y minus the square root of y squared. And so if I do this out, 2x squared is 4x squared, and then the square root of y squared is minus y. Okay, and now down here I have, it looks a lot more confusing because it has a lot more stuff. But it's not any more it doesn't have any more stuff really. We just have our two parts again. We have x plus y, minus 1, plus 1. So we'll have x plus y squared minus 1 squared. So I'll have x plus y squared minus 1. And that will be my final answer. Sorry that fell off the screen while I was doing it. Okay, example 6 is something that we haven't done for a while. It's factoring out a common term. And so what we're going to look for when we're factoring out a common term is we're going to look for something that's the same in both, and try to make it so our expression is easier to use. So if we look at A, we have 3x squared minus 6x. So I go, okay, what goes into both 3 and 6? So 3 goes into both 3 and 6. 3. And then I look, do both terms have an x? They do. And what's my lowest power of x? My lowest power of x is over here, x to the first, so I'm just going to leave it as 3x. And then if I take a 3x out of 3x squared, so if I divide a 3x out of 3x squared, if I divide 3 by 3, I get 1. And if I take an x out of x squared, I'm going to be left with x. And then if I have my negative 6, if I take a 3x out of negative 6x, if I take a 3 out of negative 6, I'm left with a negative 2. And the x and the x will divide each other out and make a 1 pair, so I don't really need to care about it. So I'll just get 3x times x minus 2. Now for b. B is a little bit more complicated because it has more terms and more stuff. So I look through 8x to the fourth, y squared, plus 6x to the third, y, minus 2x, y to the fourth. And I say, okay, so what's in common between 8, 6, and 2? So the number that's in common between 8, 6, and 2, the number that goes into all of them, divides into all of them evenly, is a 2. So I'm going to take a 2 out. And then they all have x's, so I'll take an x. And what's the lowest power of x? The lowest power of x is over here, x to the first, so I just leave it as that. And then over here, they all have y's. What's my lowest power of y? It's right over here. I have a y to the first. So my lowest power of y is y. And then, okay, so how many times does 2 go into 8? 4 times. How many x's are left over if I take 1 out? There are 3 x's left over from there. And then y squared, take away, divided by 1y. Remember, you just subtract the exponents, so it's just y. So plus, if I take a 2 out of 6, what's left? A 3 is left. So then if I take 1x out of x cubed, I'll be left with x squared. And if I take a y out of y, those will cancel each other out. And then I have my negative 2. So if I take a 2 out of negative 2, I'm just left with negative 1. And then an x out of x will leave me with another 1. And then I'll have a y, taking out a y to the fourth, so I'll be left with y to the third. And then on to c. c is 2x to the fourth times x minus 3 minus 5 times x minus 3. So this looks really complicated because it has all this stuff over here. But it's really all this stuff times x minus 3. Over here I have 5 times x minus 3. So both terms have an x minus 3 in it that I can take out. So I'll take that x minus 3 out, x minus 3. And then in this term, if I take an x minus 3 out, I'm left with 2x plus 4. Over here, if I take an x minus 3 out, I'll be left with a minus 5. So I forgot a parentheses, so it's right there. Okay, so that's all the time we're going to have for in this video. I'll make a next video with the next examples.